friends, now I am going to start about Numericals of Determinants class 12 chapter 4. In this topic I am going to discuss some numericals, that how we can solve or evaluate the determinants without doing much calculations and using the properties of determinants. In the numericals we are going to discuss about the properties, and using that properties I am going to solve the determinants in a much simpler way. You can see, let's discuss the questions. Question number first. In this question it is given that x, y, z are different and determinant is given which is of the order 3 cross 3 which is equal to 0. Then we have to show that 1 plus x, y, z equal to 0. In this question these three variables are different, means they have a different value. So let's solve this question. Determinant is x, y, z, x square, y square, z square, 1 plus x square, 1 plus y square and 1 plus z square. Now by using the properties of determinant we can break down this determinants in two determinants. Means using the property 5 of determinants, if any term is given as or any element is expressed as sum of two or more than two determinants, then that determinant is also expressed as sum of two or more than two determinants. So this can be break down as x, y, z, x square, y square, z square, and this can be break down as 1, 1, 1 and plus x, y, z, x square, y square, z square, and the determinant is x, y, z, x square, y square, z square and 1 plus x cube, 1 plus y cube and 1 plus z cube. So we write down the determinants, and using the property 5 of determinants, that if any element can be expressed as sum of two or more than two terms, then determinants can also be expressed as sum of two or more than two determinants. So we have expressed this determinant as sum of two determinants. It is first determinants, and the second one is x cube, y cube and z cube. Now let's solve this determinant. X, y, z, x square, y square, z square, 1, 1, 1. Here you can see that x is common, y is common and z is common in all the row. So we take out the common x, y, z from each row. Here x is taken as common, so we get 1 x and x square. Here y is taken as common, so we get 1 y and y square. And the third row is 1 z and z square. X, y, z is taken as common. Now you can see that these two determinants look similar, but only the position of elements are get different. Means 1, 1, 1 is present in the third column and here it is present as first column. So what we have to do, we have to only exchange the columns third with first, and this column get exchanged with second. So when we exchange any columns on any rows, so what is the difference in the determinants? Only sign gets reversed. That if we are going to make this determinant same like this, so what we have to do, we have to only make some changes in this determinants. Using the property second, if we change any columns with interchange any columns with any other columns, then only sign gets changed. So let me here, we have to make this determinant same like this. So means we have to exchange columns. So this column third we exchange with column first. So 1, 1, 1. I have exchanged this column and we get x, y, z in this place. And the middle row is same as it is, x square, y square, z square. If we interchange the determinant, so what is the difference? The difference is of negative sign. Means this is negative time of this. So we have taken only the difference of this. Plus x, y, z, 1, 1, 1, x, y, z and x square, y square and z square. What we have used column operation, that column third is exchanged with column first. Only this we have done, and if we have do this, then there is a difference in the determinants, and that of only negative sign, means this determinant is negative time of this determinant. Now we have seen that column first gets similar, column first is same, but now column second and column third are different, means now we have to exchange these two columns. So in order to exchange these two columns, and in order to exchange these two columns, we have to use column operation, that column 2 is replaced with column 3. So again negative sign come, negative times of negative become positive. This is already there, ये negative sign पहले से था. अब now we are making this column exchange with column third. So what we get, 1 1 1 x y z x square y square and z square. And if we do this, then the difference in these two determinants is of negative sign. So to make same, so we have written here negative sign plus x y z, 1 1 1 x y z x square y square and z square. Now we can see that our determinants, both our determinants become same, and in order to make this only, we have used two column operation, that we have exchanged column 3 with column first and column second with column third, and we have making the determinants same. Now we can take out common easily. What we have to take determinants common here. So we get 1 1 1 x y z x square y square z square. We have taken that determinants common here. Here negative multiplied with negative sign become positive, means no difference is there, and what we get, 1 plus x y z, and it is evaluated to 0. It is given in the question. Given in the question only. We have simply make or evaluate these determinants, and we have come to that point, or this is equal to 0, it is given in the question. Now we have to prove that. We have to prove that 1 plus x y z is equal to 0. It means that this quantity, this whole quantity have to become 0, and in order to make this determinant 0, we have to evaluate it or solve it. So using the properties, let's evaluate. In order to evaluate determinant, to solve determinants, the best way is to find out maximum number of zeros. कितना हम zero बना लें, then we can easily solve the determinants. And in order to do this, we have to apply some row operations or column operations. If we subtract this first row with second, we can easily get zero in column first, and if we subtract this column or row second with third, then also we can get zeros, means we can get zeros, maximum number of zeros, and this is the best way to evaluate any determinants. Now solve this. What is given? 1 1 1 x y z x square y square and z square. 1 plus x y z is equal to 0. We have to solve this determinants. So let's subtract. Let we apply some row operation, that row 1 is row 1 minus row 2, and row 2 is row 2 minus row 3. So when we minus row 1 with row 2, we get 0, x minus y and x square minus y square. If we minus subtract these two rows, then we get 0, y minus z and y square minus z square, 1z z square. We get this determinant. Now we can solve this. If we get zeros, if we expand this through along column first, then what we get? 0, hide this quantity, 0 multiplied by anything. We have to multiply z square y minus z minus, इन दोनों को हमें multiply करना है. We get z y square minus z square. Now negative sign, this 0 will come multiplied with z square x minus y z x square minus y square plus this one, hiding that rows in that column, we get x minus y, y square minus z square, x minus y, y square minus z square, and what we get, y minus z, x square minus y square, y minus z, x square minus y square. This. We know 0 multiplied by anything is 0. So here this get cancelled out to 0. This is also cancelled out to 0. And we get this only. What, which is x minus y and y minus z. You can easily see that x minus y and y minus z can be taken as common. So what we get? X minus y, y minus z is taken as common. What we get inside? Y plus z and x plus y minus of x minus y, or here bracket 1 plus xyz, which is equal to 0. This y get cancelled out, this y, and we get x minus y, y minus z, z minus x, and 1 plus xyz, which is equal to 0. And in the question it is given that x, y, z are different, means x is not equal to y, y is not equal to z, and z is not equal to x, means these can't be equal to 0. So what is the result? The result is 1 plus x, y, z is equal to 0, and hence proved. This we have to find that 1 plus xyz is equal to 0, and we have proved that 1 plus xyz is equal to 0. So first what we have to do, we have taken the determinant, simplify it in a simple manners. We have applied the property fifth, split the two determinants. By splitting two determinants, we see that all the elements in the two determinants are same. Only their order of placement is different. We make that order same by using the column operations. Then we have taken the determinant commons. We get the term 1 plus xyz, or it is given in the question that determinant is equal to 0, and we then put it equal to 0. Solve the determinant in the simple manner by making the number of zeros. By using the row operations, we can easily solve that determinants. We get this expression, and it is given in the question that x, y and z are different. Then we get the result 1 plus xyz is equal to 0, and hence proved. Now I am going to discuss next question, determinants. Question number 2. It is the second question. Using the property of determinant, we have to solve this determinant and 0. This is our question. So in this question, we have to use simply the properties of determinants which we have discussed earlier. Now it is given that all the elements in the determinants are expressed as sum of 2 or more than 2 terms. Then we can easily express the determinants in this form of sum of 2 or more than 2 determinants using the property 5, and we have to apply this property only. What we get? X, y, z, a, b, c, x, y, z plus x, y, z, a, b, c and a, b, c. What we have taken, we have only split the determinant as a sum of 2 or more than 2 determinants using the property fifth. Now we can see that here column first is same as column third and column second is same as column third. So what we have seen, the two columns are same. Then by using property third, that if two columns or any rows are similar in the determinants, then the value of the determinant becomes 0. So this quantity becomes 0 and this is also becomes 0 by using the property third. So what we get, the answer is 0, hence proved. What we have to prove that. This is question number 3, that using the properties of determinant, we have to evaluate this determinant and make it simpler as 0. So what we have to do means we have to simply use the properties of determinants which we have discussed. So let's see, this is column first which is given as 2, 3, 5 and it is 7, 8, 9. So if we look this determinant and multiply 9 in it, so what we get, 7 9s are 63 and then we add 2, we get 65. 8 nines are 72 and we add 3 we get 75, and 9 nines are 81 and if we add 5 we get 86, means this can be expressed as in form of expression by multiplying 9 in column second and then adding column first. So let's see, 2, 3, 5. If we make this column same as this, what we have to do, we have to use the column operation, that column second become column 9 multiplied with column second plus column first. So if we multiply 9 in column second, we get 7 nines are 63 and adding column first 65. 8 nines are 72 and adding 3 we get 75, and 9 nines are 81 and if we add 5 we get 86, and the column third is written as same as it is given in the question. Now what we have seen here, we have seen that these two columns become same. Then again we have to use the properties, that by using a property third, that if any two rows and any two columns become same, then we get the value of determinant as 0 and hence proved. What we have used here, we have only used the one column operation, that column second can be expressed as 9 multiplied in column second adding column fifth. Then what we get same as the element present in the column third, and if the two column become same, then the value of the determinant becomes 0 and hence we have find out.